What's up guys, Shawnthebro here, and in today's episode of the first person shooter tutorial series, we are going to be going over shotguns part 2. So specifically, we're going to be giving shotguns a certain number of pellets, and we're going to space them out so it looks like a shotgun shell blast. Coming over to my weapon, this is what I have as my shotgun. It's called the leader, and I can use this, and the shells are going to come out like this. Now I've given them almost no velocity so you can see the pattern. But they come out in essentially a random pattern. The number of pellets we specify is 8, and they're going to come out like this in some sort of pattern that is then going to be used to damage the opponents if it hits them. Now this is the method using actual projectiles. We are going to use a shotgun hit scan method as well, but it's going to be slightly different than this one, so we are going to implement that in the next episode on shotguns. Now, if you want to get caught up in the series before checking out this episode, you can see everything we've done in this playlist right here in the top right corner. Alternatively, if you only care about shotguns, I will recommend you watch the first one, since this logic is going to be building off of that episode. I'll link that right here in the top right corner. And with those out of the way, we can go ahead and get started. So, this is a code and blueprint tutorial series. We are going to start in the code today. Now, in the previous episode, I mentioned you could have this base shotgun class that you use and have your shotguns all be children of this base shotgun class, so only shotgun behavior is in this class, not in the base weapon class. I also said it's okay if you want to put it in the base weapon class. It just means that some of your weapons will have variables that they don't need, such as the number of pellets that are shot out. Normal weapons may not need that, but they also may. You could have weapons that are not shotguns that do have several projectiles that come out of it. A good example of this is the triple take from Apex Legends. 3 different projectiles are shot with 1 consumption of ammo. So it doesn't have to be a shotgun. This can be used for other weapons. So depending on your game, you may want to put this in a base shotgun class like I have here and like I explained in the previous episode. I'm going to do it in the base weapon class so that all my weapons have this functionality, but we are going to only use it in the shotgun at the current time. Now, just showing you, this is what my base shotgun class looked like. I am going to change the name from num pellets to num projectiles per ammo, because it's not really pellets. If we're talking about multiple weapons using it, then it doesn't mean it's pellets, doesn't mean it's shells. It just means this many projectiles are being spawned per 1 instance of ammo. So if you were using the base shotgun class, you could change it like that. But let's go to the base weapon, where I did it in the previous episode, and we're going to continue along in this path. I'm going to scroll down in base weapon to where my previous variable was, num pellets, and I'm changing that to int num projectiles per ammo. I changed the category from shotgun to weapon because it doesn't just have to be for a shotgun. This is what it looked like in the previous episode. This is what it looks like now. So I'm actually going to get rid of the old logic, and I'm just going to have this new variable in here now. And again, this is what we're using for the number of projectiles when 1 ammo is consumed. Now I want to go to my baseweapon.cpp, and where I was filling out num pellets and setting it to 8, I'm going to take that away because we don't want the base weapon to have 8 pellets by default. Plus, I'm also going to change it to my new variable, so num pellets equals 8 becomes num projectiles per ammo equals 1. We can get a little bit fancier in here as well if we make another variable. Let's make a float this time, and we'll call it float horizontal spread, and we'll make this uProperty of edit anywhere blueprint read write with a category equals weapon. The comment, the horizontal spread, let's actually say the maximum horizontal spread of projectiles when multiple projectiles are spawned with 1 ammo consumption. So basically, this is going to be our range that we have for when these projectiles come out. If they are not always in the same pattern, this is going to be the maximum horizontal distance that we can use. So if it's 40 units, the projectiles can be anywhere within that 40 unit radius. Now let's go ahead and make one for our vertical spread as well. maximum vertical spread of projectiles when multiple projectiles are spawned with 1 ammo consumption. View property of edit anywhere, blueprint read write, and a category of weapon. Say float vertical spread. And actually I'm going to change both these categories to be stats. They are stats of the weapon. They're not the generic parts of the weapon. These are configurable for each weapon, so let's go ahead and assign that properly. Now we can go back to the constructor base weapon where we set all the default values once again, and in here I'm going to set my other variables here. I'm going to put them all together. So these are all my burst projectiles, put them together, put the number of projectile behavior together as well. So we're going to say vertical spread equals 0 by default, and horizontal spread be 0 by default because, again, we're in base weapon, not base shotgun. If we were implementing this with base shotgun, you could easily assign all 3 of these variables with higher values if you wanted an actual maximum or minimum for shotguns. But as far as all weapons go, they don't need to have any vertical or horizontal spread, and they only need to spawn 1 projectile per ammo consumption. So I'm going to start them like that. The editor is open, so we can go ahead and assign our values to our weapons for the variables that we just made. So first place we can start is base weapon, BP, and go into it. Look at the class defaults. In here, we can assign our number of projectiles per ammo, our vertical spread, and our horizontal spread, but we don't need to. Again, this is our base weapon. It would be better to do it for each of the weapons individually. So go ahead and open up all your weapons. For me, they're in first person. FP weapon, weapons, and then in here I have my assault rifle, my submachine gun, which are also going to stay the exact same. So for me, I'm only going to do this on my shotgun BP. I'm going to open this up and I'm going to set all my variables. So none projectiles per ammo, we're going to spawn 8 projectiles when we consume 1 ammo. Then for the stats, the vertical spread, the horizontal spread, let's go ahead and set them to different values. For the vertical spread, let's say 30, and for the horizontal spread, let's say 40. This is a number you're going to have to play around with. I have tested this a bit, and I feel like those are pretty good numbers, but it really depends on your shotgun you're using as well. Once you've assigned values for all of your weapons, go ahead and go into your base weapon BP, spawn these projectiles every time fire weapon is called. So fire weapon's called in the code, then there's a blueprint event that gets called as well, and we determine whether to spawn projectiles or ray traces or hit scans. In today's episode, we're just focusing on the projectiles, so we're actually going to want to go into the spawn projectile at crosshairs function. Now this function has been worked on many times throughout the series, so you're probably familiar with it if you've been following along. Essentially, we get the camera component that we're using to determine where we are aiming, get the location and the rotation of it, so that we can determine where to spawn this projectile from the weapon. And we were doing that for assault rifle, pistol, submachine gun, and shotgun. Shotgun's going to be a little bit different now. So specifically, the shotgun branch comes down here, and we're going to do all of this logic for shotguns. Before, we were just spawning the shotgun ammo BP actor, passing in self, or the weapon as the owner, the projectile speed for the speed, the projectile drop-off for the drop-off, and going about our day. Now what we have to do is spawn our correct number of projectiles per ammo consumption, and we need to also factor in the vertical and horizontal spread for where those projectiles should be at. So here's a very simple algorithm I have to do that. First thing I want to do is get a random value, and to do this I can use make random stream, and then retrieve a random value from that stream. The stream requires an initial seed. So if you've ever seen in a game with random elements, you can put in a seed and get a desired outcome. This is the same thing. That's what that's talking about. However, I want it to be fully random, so I just went ahead and made a random integer in range of 0 to 100, passed that in as the seed, and then retrieved a random value from that stream created from the seed. Long story short, we are going to look for random integer in range. And you can put in whatever values you want in here, really. I just did 0 to 100, that's more than enough for my use cases. But this is essentially treating it like there's 100 possible seeds we can use here for this stream. So 0 to 100 is perfectly fine. Feel free to use that if you want. Then we can drag off that return value, and whatever the random number is that gets generated here, we are going to use make random stream, using that return value as the seed to actually get a random stream structure. As it says, it makes an srand based random number generator. So we can drag off of this and now type in random integer in range from stream. And now we have a min and a max. So this is going to be our min horizontal spread, our max horizontal spread, and our min vertical spread and max vertical spread. At the moment, I've hard-coded them all to be -40 to 40. But we're going to use those variables that we created in the code to actually make this much more easily configured. We're going to need two of these nodes because we need two of this node because we need one for the Y and one for the Z, which is essentially our horizontal and our vertical position, whereas the X is the depth, and we don't need it to go closer to the camera or farther away from the camera. You could actually use that if you want, but I'm not going to do that in today's episode. Now, I want to use our variables that we made, so you could use the random integer in range from stream here and just convert our floats to integers just by passing them in. So for example, if we have this first one here that's going into our Y value, we can go ahead and use our horizontal spread and plug that into the max, and it will truncate it. Or you could use random float in range from stream. It's not required that you use floats here, but since I was making a variable for it, I did want to give it as much customization as possible. The seed, the one that's generating the seed, can stay. I'm just going to change out these two nodes. Random integer in range from stream, I'm going to drag off of my stream. Random float in range from stream. And I'm going to delete these convert nodes that I had that I don't need anymore. And for the min and the max, I'm going to use my proper variables now. So this first one is for my Y, so I'm going to use horizontal spread. I'm going to get that. I'm going to use it as my maximum. For the minimum, I'm just going to do the opposite, so I'm going to multiply. So float times float, -1. So if we assigned it 30, it can go from -30 as the minimum to +30 as the maximum. For the other one, we're going to use our vertical spread. So right click, vertical spread. We can multiply float times float, -1. Pass that in as the minimum, and the vertical spread can go in as the maximum. And something like that will do the trick. So now I have two values, one for my horizontal spread, one for my vertical spread. I want to use these, and really what I want to do is offset the already calculated location by this amount. What I mean by that is up above, I mentioned we were using our camera's location to determine the transform of the ammo we were spawning. That ammo was being brought into the transform on the spawn actor, in this case a shotgun ammo BP. But I want to actually drag off of this transform and break it. Break transform. We'll get this node right here. This is all the individual components that make up a transform, so location, rotation, and scale. I can right click on my location and split the struct pin to get all the individual components of a location, which is an X, Y, and Z float. And those values are the ones we want to change, specifically the Y and the Z. The rotation and the scale can be left alone for now, as well as the location X, if you're like me and you don't need to modify the depth. But for the Y, we want to add our offset, so float plus float, and same with the Z, float plus float. And that's how you'll get these nodes that you see right here. Now, for the value we're adding, instead of adding 0, add the random value we get from the stream. The horizontal spread should go into the Y, and the vertical spread should go into the Z. There we go. Now, we have to make a new transform because the spawn actor from class node does require a transform. So we're going to type make transform. And we're going to right click on the location and split it again, and we're going to pass in the scale, rotation, and the X from the break transform. Then the result of the addition from the Y is going to go into location Y. The result of the addition from the Z is going to go into location Z. We get this new return value, this new transform. That's what we have here. So we should still have the spawn actor shotgun ammo BP node. We can pass in our make transform, and we can pass in our 3 variables that we're using for all of our ammo: self, projectile speed, and projectile drop off. Now the only thing we need to do at this point, do this for the correct number of projectiles, and that is determined by the num projectiles per ammo variable that we have in our weapon now. So before we call spawn actor shotgun ammo BP, we are going to grab our num projectiles per ammo. So get num projectiles per ammo. Then we're going to search for a for loop, not a for each loop, but a regular for loop. So we determine the first index and the last index. The num projectiles per ammo is the last index. We can start at index 0. And for each loop, we want to spawn one of these projectiles. So that's it. On loop body, plug it into your spawn actor, shotgun ammo BP, and you're good to go. Now at this point, we can play our game and make sure that everything is working. So we can go into our match, go to our shotgun, and when we shoot, we should see a nice spread. And there should be 8 projectiles that are spawning. I'm actually spawning 1 too many, I just realized, because my last index of 8 is going from 0 to 8, not 1 to 8. So I do want to subtract 1 from num projectiles per ammo to get the proper number of projectiles. So num projectiles per ammo minus 1, and plug that in as the last index. We've successfully implemented shotgun spread for projectiles. Anyway guys, thank you so much for watching. If you enjoyed, please subscribe. It does more for myself and the channel than anything else you can do. I really appreciate that. Consider joining the Patreon, YouTube membership, or Discord subscriptions for more perks from the channel, including getting these series for free when they're up on the Epic Marketplace. If you had any issues with this tutorial or any of my tutorials, feel free to join the Discord community. There's a link in the description. That support is completely free. But anyway guys, like I said, that's all I got. So thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye guys.